Welcome to the Infoware Local Data Warehouse presentation video. In this presentation we will cover 4 chapters. First is data warehousing as a reporting tool and its background. Next, we will talk about the Infoware Local Data Warehouse. What it is, its benefits for reporting, and also how it can be used. Data publishing can be done using Microsoft Tabular OLAP and Excel. And last, how data from the local data warehouse can be combined with Infoware. Chapter 1, Data Warehouse as a Reporting Tool. Data Warehouse offers single source of reporting, having all data in one place. Same data is used for different reports and analysis. Model of the data warehouse database is maintained clean and understandable for all the users. The data in the data warehouse can be combined from a lot of different sources, stored in the same model, used in one or different reports. Data is maintained by a timeline, monthly or daily, going back to desired history, which is enabling historical reporting. Data load is managed by users and it is traceable to the time, source and user that executed it, making it open and consistent for audit and debugging purposes. Infoware Local Data Warehouse is a standardized system and it operates on common and widespread Microsoft technologies. It offers full data lifecycle management, and it can be easily integrated with Infoware data. One of its strongest benefits is the efficient maintenance and easy knowledge sharing, which enable fast development of new requirements. Depending on the new business requirement, it can result with simple change of the Infoware Local Data Warehouse database model, like adding a new attribute, dimension or a fact. After that, next is to develop a data extract or calculation logic, and last is changing the data output medium, OLAP or report. Once the new data is loaded, it can be used for the business reporting purposes defined. Using the powerful tabular OLAP, customized OLAP cube solutions can be developed and changed very fast. Tabular Tools interface is very simple for usage, and it is almost the same as Excel Power Pivot. Using Microsoft Excel to connect to the designed OLAP cube, you can use the published information in many different ways. The example here presents a KPI on client transactions volume and their settlement channel over a short timeline. Same information can be embedded as part of many different reports, used for analysis or assist in more efficient decision-making. Chapter 2, Sample Usage of Infoware Local Data Warehouse. Infoware Local Data Warehouse takes advantage of several Microsoft products. Using integration services packages, .NET Framework and SQL Server features, Infoware Local Data Warehouse is a powerful data warehousing tool. Different or a single ETL can communicate with different sources, combine and load the data into the data warehouse. Having an extract script as a communication link with the source, the ETL SQL code generator takes metadata from the data warehouse database, and the configuration settings to produce the full ETL of a data entity. ETL is completely TSQL-based, embedded into the integration services package. This package is managed by the Windows.NET Task Engine service, enabling the user's full control and monitoring on the ETL process over the web application. ETL is communicating with the source and destination databases, as well as with staging and log databases. All of these tools combined together enable high flexibility and fast development of a local data warehouse. Using the Kimball methodology makes the Infoware Local Data Warehouse very efficient for agile development, and the model understandable and standardized. Each data entity can have one or more ETL processes, where dimensions can be historic or current, and fact tables related with day or month timeline units. Different data mart models of the warehouse can easily be shared or adapted between Infoware and the local data warehouse. This sample database model of an Infoware Local Data Warehouse implementation contains several fact tables and dimensions. It will be used as basis for the next part of the presentation. The requirements that define the sample are the following. Client source of income information is needed for reporting and client transactions analysis. Source of income should reflect the employment information of a private client. Next we will present the full process of how to add and adapt the Infoware local data warehouse solution. We must start with adding the needed table in the database. Database diagram feature of the SQL Management Studio enables adding a new table to a database. Income source is a DIM party parent, so we include the load table and the party dimension, displayed in standard view. Now we add the new table. We use standard naming with DIM prefix and the entity name, DIM income source. We will use the income source for the table key and ID columns. We create income source key as small integer column. It will be the dimension primary key. Next we create income source ID as nvarchar, and this column is the unique business identifier of the dimension record. Last we create the description column as nvarchar of 400, called name local, and also we create the two load metadata keys. They are named created load key and modified load key, and they are foreign key to the load table, where we have information about source, date of load and the user. We now set the income source key as primary key of the dimension. It is expected that the key will be a surrogate key, so we enable the auto-increment value using the identity specification. Income source is a parent dimension of the party dimension. A column in the party dimension should be created, which will be the foreign key linked to the source income dimension. Name is the same income source key, and the data types must match. Then we create the foreign key with easy drag and drop. To avoid a mistake, please check if the column names of the primary key and the foreign key tables are correct. Once we make sure that the foreign key exists, diagram and all changes can be saved. When saving over a visual editor, it can affect many objects of the database in an unwanted manner. This can be a big problem once the data warehouse database is filled with a lot of data. This is one of the main reasons to use SQL data definition scripts to achieve the same result. Creating the source income dimension table, source income key column in the party dimension, as well as all foreign keys, can be done in an efficient and transparent way when the SQL DDL statements are used. Using the Object Explorer you can check if the new table DIM income source is correctly added in the database model, as well check for the income source key column, if it is added to DIM party. Model changes usually require configuration of the ETL engine metadata. Using the Infoware local data warehouse web interface we are managing the ETL configuration parameters of the new table, DIM income source. DIM income source is a regular dimension, for which we use the default settings of all parameters. Main part of any ETL is the extract. Using the query feature of the staging data source, extract query statement template is offered, customized by the selected table. For DIM income source we will be using a direct query to the employment statuses classifier table of the customware.net database. The query is selecting the two mandatory columns for the DIM income source dimension. Other columns of the dimension table are automatically filled by the ETL process. Order of the ETL tables is important for the full data load execution. DIM income source table is parent of DIM party, and it must be ordered before the DIM party table. In this way, the full load sequence will first load data in the parent table, and then in the related child table. DIM party is a historical dimension, and income source should become historical attributes as well. Using the same metadata interface we will add the income source key to the list of slowly changing type 2 attributes. Using the query edit feature, we must add the source for the new attribute of DIM party, adding the joint to the corresponding classifier table of the source. Next the select of the employment status identifier is added as a source for the income source data column. Last and mandatory, We also add the link local data warehouse column, as part of the insert into statement, to the staging table. And we save the table metadata. After table configuration is saved, data load tasks are available for execution. Using the task list, we can choose the DIM income source ETL task, and execute it. Another option is to schedule a task to be executed on a specific date and time. It is done using the same interface, just we specify exact date and time when we want the task to be executed. We can choose or write in the date and time. When a task is running or scheduled for future execution can be seen in the Active Jobs section on the home page of the web application. Short list of jobs and execution details were in the Executed Jobs section. Job summary is available for all executed tasks, containing details from the task execution. Jobs page offers details on all scheduled or executed tasks. On the Jobs page we can see status of tasks that are not already finished, but also scheduled tasks. Using the job summary we can look into details on errors that occurred for the failed tasks. Besides date and time of scheduling parameter, some tasks have other parameters. The full load task requires reporting date as input parameter. By inputting the wanted reporting date, and leaving schedule date empty, execution of the full load task will be started immediately. This can be seen on the home page, as mentioned earlier. Every task in Infoware Local Data Warehouse is composed from one or more SSIS packages. ETL packages define parameters for their usage. Our example dimension task, DIM income source, its ETL package has no parameters defined. Sample package variable which will be used as a parameter will be named test date. Each parameter should have understandable description. Test date parameter will be defined as a date time type parameter, and it will be required. Required parameters must have a default value defined. Going back to the income source ETL task and package metadata information page, we can see that the newly added parameter is in place. Now, when we go on the execution action of the DIM income source ETL task, we will be asked to input the test date parameter and then run the task. Single task can be composed from one or more packages. Using the task's administration interface, packages can be linked to a task. Editing the links of a DIM income source ETL task, we will link the DIM currency ETL package to the task as well. After it is linked, order of the packages can be defined. Executing the income source ETL task will ask for the test date parameter we added earlier. After completed execution, in the job log of the task, we can see which packages were executed. In the case of this task, we have both DIM currency ETL package and the DIM income source ETL package executed successfully. Chapter 3, Publishing and Reporting Data, Tabular OLAP and Excel. To publish the new data added in our local data warehouse, we need to change the design of the OLAP cube. The sample tabular OLAP solution uses user-defined views on database level, as a source for the dimensions and measures. To add the source of income information, using the Microsoft SQL Management Studio, we will alter the local data warehouse tabular client's view. To this view we need to add the information about the source of income. First we join with DIM income source table, and then we select the description we want to see in our OLAP cube. After view is altered, we are going to edit the tabular OLAP solution. We open the transactions cube model, and the short client dimension. We can notice that the income source attribute is not part of the dimension. Using the dimension source, we get the refreshed model of the source, which includes the income source attribute. Simple select includes it in the OLAP. When change is applied, tabular OLAP collects data from the table, as it maintains a temporary workspace database which is refreshed on save. To see the complete process, we will deploy the OLAP database. Deployment process also processes the OLAP database. Sources of the tabular OLAP solution are the local data warehouse database and the Infoware database. After the OLAP database is deployed, we will use Microsoft Excel to browse it. On an Excel worksheet, using the Data tab, we take data from an Analysis Services server. After a server name is provided, databases and the cubes available are listed. We select the local data warehouse transactions database and the model cube. Pivot table report format of the cube data is applied. Pivot table fields of the OLAP cube are offered on the right side of the screen. We choose the count and amount sum measures of the transactions. Then we apply the income source attribute of the small client dimension as a row field. More complex structure of the report can be built by using additional attributes for analysis. For example, the Infoware product group can show the client income source categories on different levels. Chapter 4, Data from Infoware and Local Data Warehouse. Using the same dimension and fact modeling methodology, and Microsoft SQL technology, the Infoware database can be used via OLAP solution. Infoware already contains a large set of clean, debugged, and historical data, stored in the financial and operational data marts, which includes treasury data as well. Link between the local data warehouse and the Infoware model can be achieved easily using business identifiers, enabling access to the rich set of Infoware Snowflake dimensions and attributes. In our sample tabular solution, source of the transactions fact table is the local data warehouse database. Source name is transactions view from the tabular schema. The contracts dimension is linked with the transactions over the Infoware contract key column, which is a calculated column on the level of the transactions view using the Infoware linked server object. Contracts dimension source is Infoware. Standard output schema view dim contract is used, and it offers a lot of contract-related attributes, which are part of the Infoware database. However, not all of them must be included in the tabular OLAP solution. The local data warehouse party dimension contains only few attributes. This is why the full client dimension is also sourced from Infoware. Source is the output schema view dim party, and as the dim contract view, it contains a lot of usable attributes. Data combined from both sources is easily used from Excel connected to the OLAP database, without the users being aware of the complexity of the background source of data. We completed our short video of the Infoware Local Data Warehouse functionality and feature usage presentation. Thank you very much for your attention.